Good afternoon. Welcome back to the channel. This video is not financial advice, not a financial advisor. Do your own research, make your own decisions. Okay, guys, welcome back. So in this video, I'm going to be comparing Caffeine AI and AI-powered applications on ICP to Web2 competitors. And I wouldn't even look at them as competitors because the properties of software are so drastically different. But before I get started, I just want to go over the inspiration for this video. I read this comment from Dom like a week or so ago, and I want to unpack it in this video. So once self-writing results in an explosion of apps, either A, they live within closed platforms, and we'll go through that, such as Lovable, and app owners trust the operators with their security, or B, they are tamper-proof and movable, and we'll definitely go into the movable part of this, comparing the closed nature of Web2 to the very open and flexible nature of ICP, and traditional cyber defenses isn't necessary. So we've been over this in general to some degree months and months ago, like 8 or 9 months ago during my long video series about this. But there's two main ways that ICP simplifies the software stack for AI itself and AI powered applications. ICP is more optimized for AI and self-writing apps because it eliminates the complexity within software systems. But the second part is what we're going to be going over in this video more specifically. It simplifies the software stack across software systems in the communication software system to software system. And this is just one major differentiator for Caffeine and ICP versus Web2 self-writing apps. And there are tons of others. Okay, that's why it took so many videos to go through every single differentiator. But they're more so related to Web2 architecture and the inherent problems with Web2. Nothing It's not necessarily that Lovable or Replit or any of these other companies or AI products are just incompetent. It's more so the framework that they've deployed their solution into has way too many limitations when compared to ICP. So, and at the end of the day, I wouldn't look at them as competitors because they can also deploy on ICP over time. And in my opinion, I think they're probably going to because it just makes all the sense in the world and it gives them a whole new value proposition for all of their users. So we're talking about two different software systems or two different people. The same concept applies, communicating with each other and collapsing the distance between two different points that are trying to interact and communicate with each other. So on ICP, everything's in canisters. So the communication is canister to canister. You don't have all this friction in between when you're trying to have software systems communicate with each other. But if you think about how we interact on Web2, and all of our communication is traveling across tons of different systems, all bundled together, all interacting via API calls. Okay. And these are just some of the systems that you would see tied into any given application, but there's tons of other systems that make up what we see as our web and what we experience as our web today. Okay. And the more and more systems, the more and more the attack surface starts to increase, and the more friction and complexity just to have two different software systems interacting with each other. So the thought experiment is going to be 100 people on Web2 use AI self-writing applications to build them a website and or a mini social app for them and their personal network, okay? And then 100 people do the exact same thing on ICP with Caffeine. And so the thought experiment starts from that point, post build out. And what we're looking at, what we're comparing is how easy or difficult it would be for different apps to communicate, integrate, fuse, merge, and utilize each other's network effects to mutually benefit. And so just think about the future of social networks, interconnected social networks, and this is very, very relevant to any and all conversations about metaverse. And again, I would look at it more so as a closed model versus a open, movable, composable model owned and operated by the users. So that's where the thought experiment picks up. I wasn't going to put 100 canisters on this screen, but just imagine this is 100 canisters, and this could be my website or mini social app. This could be yours, and so on and so forth. All right. And then on Web2, again, just imagine this is 100 different mini social apps on Web2 built by AI application builders. All right. And we've been over a lot of the problems when it comes to communication system to system on Web2. They could be using different cloud providers. They could have different database management systems, different firewall configurations, content delivery networks, access and permissions. They could have been written in different programming languages. There's near infinite ways that software systems could be different in some way. The more differences between systems, the more complexity, the more work that needs to be done to have any type of integration between those systems, and the higher the attack surface. Now, if we were to zoom in on A, again, A is my personal website or social app and or yours. But if we were to zoom in on A, you're going to see a bunch of different systems all bundled together because Web2 uses an integrated system architecture. Now, these are just some of the types of systems that you would see tied into any given software application on Web2. But beyond this, you would also have the large language model, right? And the company. Think about how many different centralized companies are tied into one application. This is insane. If you wanted to build your own mini social app on Web2, you're talking about 6, 7, 8, 9, maybe 10 or more different centralized companies' systems, all intertwined with one application. Now, on top of what you see here, you would also have the large language model and the AI company, right? And you would also have the self-writing application company, which would be like a Replit or a Lovable. So tons of different centralized companies all intertwined with this one application. And when you start talking about having full integration and the flow of data system to system, it's such a nightmare on Web 2, and that leads, all the friction and complexity leads to more of a closed model because of all the work that needs to be done to have any type of data flow and integration system to system, and because of all the security risks that come along with it. Now, next part, one app equals a bundle of different systems all communicating via API calls. Each app is like its own little island, its own little closed island. The more functionality you want and the more connectivity with other apps that you want, the more systems that you're going to need and the more work that needs to be done, the higher the security risk. So 100 small apps on Web 2 will mostly stay disconnected and in a silo. Integration or fusion with other apps requires more systems, APIs, and extra work. For example, Zapier is a software solution that, I mean, does, or software company, they do other things too, but like integration system to system is something that they do. But again, the more you want done, the more systems, the more complexity, the higher the attack surface. AI, and this is the big part, okay? Very, very, very big part. Think about the way the human beings learn, and we've been over this before, but it's worth going back into, and the way that AI learns. If you had to learn 100 different software systems just to become proficient as like a software engineer, that's going to take a long time. That's a lot of work, right? That's a lot of complexity. There's a lot of things that you could also get wrong if you have to be proficient on 100 different software systems. But if you only have to be proficient, if you have a universal application layer and standardized interoperability system to system, and you only have to know one system, that can accelerate everything, right? It can accelerate web development exponentially because you remove all the complexity. So AI has to be trained on 1,000x more systems. It's not just the systems, the total potential scenarios that could arise just throughout day-to-day activity online. And so, but on ICP, you have a shared network state and universal interoperability. And so AI only needs to know one system. 100 apps can start fusing together near instantly because all the friction and the tons of different systems are removed. And this can cause compounding network effects to explode. And so just think about digital, like economic activity online and all the friction that stops economic activity from exploding. All that friction's removed, and you're just going to have like pure creativity, composability, and all owned and controlled by the users. On Web 2, the flow and or fusion of data and or systems will be slow, brittle, and lack security. On ICP, the flow will be near instant, secure, and autonomously ran by AI with built-in permission systems all tied back to the owner's identity, and all of this can be audited because everything is on chain. So you have digital economic activity exploding because the flow of data and commerce will increase exponentially. People will be able to create social networks and services that are not possible on Web 2. Again, think about the future of interconnected social networks online and everything ever relating to metaverse. So it's the exact same concept. Everything that I'm going over is the exact same concept in the institution enterprise space. And it's probably even more impactful in that world because those are the systems that all of the institutions that run the world, those are the system that those institutions are using, and they're archaic, they're outdated, they're not secure, and that's why you have a giant IT industry. That's why you have so many different admins and everything else. You have to hire people just to manage all the complexity and all the bullshit. That's why you get emails from the IT department, and you have to spell check every single word so you don't accidentally click on a wrong link and then you download some type of virus or whatever it is. It's all related to Web2 complexity, all these different types of systems that don't communicate with each other natively. But we're going to stick more so from a social metaverse. We're not getting into the institutional enterprise software space in this video, but the same concepts apply when it comes to system and removing the friction. So 100 different social apps. This could be mine. This could be yours, and so on and so forth. They can near instantly, start fusing and merging together for compounding network effects because they're not all going to be isolated because all the friction is removed. And then you can start layering other applications on top of that because of the embedded system architecture. And so just the future of social apps on the web will look more so like this because we'll all have the ownership and the freedom to create social networks with other people of like minds. We won't be forced into a handful of social apps all owned and controlled by centralized companies where everybody is brainwashed into oblivion. We'll be able to create our own because the tools will be there for us to be able to create our own that we own and control. But if you were to think about the same exact thing, trying to do that on Web 2, it's going to be nearly impossible because could you have some degree of integration? Yes, but everything that I just said leading up into this about all the different friction, all the additional work that needs to be done, the additional systems that you need, the increased attack surface and risk of some exploit, and at the end of the day, even with all of that, even if there were a little bit more flexibility here, you still don't own it. You still have no security. You still have no privacy. And if one of these centralized companies that you're using were to blow up overnight, everything's gone. It's not on chain verifiably under your ownership. Okay. And so, again, the concept of collapsing the distance between two different points trying to communicate with each other is very, very, very relevant here. And so this could be between two different people interacting on the web and or just two different software systems interacting and moving data system to system. All that additional friction, it just creates so many problems when it comes to so many problems and barriers for artificial intelligence and just for people and in general sense economic activity online. And so the really big difference here, it's not anything again like a knock on Replit or Lovable or anybody else. This is simply about Web 2 architecture and the inherent problems that there's no easy fix, period. You can't, the fixes are they keep layering more systems on top of this, all right, and just increasing complexity. But this is really the thing, is that the brilliance with the architecture and the engineering with ICP and the amount of problems. I don't even, it's tons of problems that they've solved with one solution, tons of different problems. And it all really does come back to architecture and how the embedded system architecture has all, you don't need all these other systems because it's all built in to one fully integrated full stack solution. And guys, we're not even, think about this. Think about this. Remember the conversations about orthogonal persistence and application code and application data being separate. And when you make a change to the application code, it needs to reflect in the database. And if you change the nature of the application in the application code, you're likely going to need to change and update the database, correct? That's going to require manual intervention because of all the complexity with AI having to be able to do all of this proficiently on the fly, on command. But that's going to require we're not even getting into this, okay? This is a whole nother problem that's more so within each software system as opposed to system to system. But this is a whole nother giant problem that applies to every single AI software, AI self-writing application on Web 2 outside of everything I've been over so far, okay? And so just look at this. the number of systems, scenarios, this ties into what we were just discussing, the number of systems, scenarios, and problems AI needs to run autonomous applications on the web. On Web 2, it's insane because you have so many different systems on Web 2, and it's just growing year over year. And so AI has to be proficient in all those. AI has to be trained on all of those. Same concept with humans. It would take such a long time for one human being to be proficient in all of these different types of, it's the exact same concept with AI. Okay, but on ICP, all of this is gone. And so the training process and the the rate at which AI can become proficient across the board on ICP is going to be so much faster because it's only really one fully integrated full stack solution as opposed to as opposed to this giant bundle of different systems all tied in together. And so when you're talking about, and this goes back into what Vitalik was saying like earlier this year, talking about the number of dependencies and just increasing the potential for something to go wrong. As you increase the number of dependencies, what I mean by dependencies is you have to depend on all of these different systems bundled together, continuing to work fine. Because if any one of them, if there's something that goes wrong with your firewall provider and or your cloud-based, your cloud service provider and or your database, if something goes wrong with any one of these systems, you're going to have performance issues, right? And so the more dependencies, the more systems, the more the attack surface, the more likely things could go wrong. And if you want to have interconnected social networks, if you want to have this metaverse where there's full integration and seamless interaction, system to system, game to game, social network to social network, more and more systems, more and more the attack surface, more and more problems, the more likely that something could go wrong. Okay. And so if you just look at this as kind of like our web and many of the different providers and centralized companies that dominate the current web that we use, all of the differences. It's like, again, we went over this months and months ago, but think of it like 1,000 different governance systems, 1,000 different governance systems, right? All tied in together. And that's why the flow is so rigid. And there's so many limitations and barriers with the flow of data and with economic activity online, is because you really have hundreds of different governance systems tied in together. As opposed to on ICP, you have governance at the network level, and you have governance at the application level, and everything is simplified at the application level. All right. So we're talking about increased economic activity exploding by orders of magnitude. And you can create systems and services that are not possible on the current web, that you own, that you control, that you can monetize in any way that you want, and that are secure, verifiably secure. Same concept with institutions and enterprise. And to an equal or larger net impact, given how inefficient the institutional software stack has become, and given the fact that institutions are really the main entities running all major companies, all governments, everything else, and the systems that they're using are archaic, outdated, they're not secure, and they put giant limitations on artificial intelligence and the impact that artificial intelligence can have on the web. Once you remove all of this, economic activity can explode, and we can have a real user-owned and controlled web. That's all I have for this video. Please let me know your thoughts in the comments section below. Thank you everyone for tuning in today. This was not financial advice. Take care. Have a great day. I'll see you in the next video.